Wasabi, guys. We're going to finally try out Bonn Integration Bee 2025. Finally. About time. Now, unfortunately, they did their qualifying exam through Kahoot, and for those who don't know how Kahoot works, when you use it, it only shows the podium, sadly. So if you, I don't know, like if you click on a link on like a used game, it'll just show the podium animation and that's it. And so with that, um, unfortunately, I do not have access to the qualifying problems. We have a quarterfinals. I think there's two quarterfinals, a semifinal, third place match, and then the epic finale. So I am excited for this. For those who don't know, Bonn University is in Germany, one of the greatest universities in Germany, actually. And for those who hasn't seen my other video, I made a video on their 2024 integration bee. Here's their 2025. So I have not looked at any of the problems. So this whole thing's gonna be sight reading. Yeah, it's gonna be fun. It's gonna be very fun. Let's get started with the quarterfinals. I don't know. Is it an integral that starts? Yes, it is. Okay. I don't know is there like a time limit I have? I don't know. I don't know if I have a time limit. I'm assuming I do, but I don't know if it's 2 minutes or 3 minutes. I wish it says. That's a horrible parentheses. But there you go. That should be my answer. Okay. The intermediate way is just doing straight up polynomial division. Or I should probably write W, where you let U or W equal tangent U. Okay. This is the intermediate or advanced way. But if you're not as comfortable with geometric polynomial division, you can just go ahead and do this if it's mentally easier for you. Okay, both are still good methods. But I believe this is my answer. So let's hope that shows. It does not show the answer. Okay, well, we're just gonna, let me know in the comments. Okay, so we have this integral here. This is actually kind of cool. So, notice, I actually like this integral a lot. Notice that you have x squared plus x plus 1, and then you can factor out the same thing here, right? So what you can actually do is you can actually factor this out. And what you have is 1 plus 1 over x plus 1 over x squared, right? And then if you kind of simplify the whole thing, you actually get something like, well, you get x squared, and then this becomes x squared plus x plus 1, that cancels out. So I think you just get 1 over x squared dx. Yeah? You get negative 1 over x, 1 to infinity, that's 0 here, plug in 1. The answer should just be 1. That's a very nice beginner integration bee problem. I really like that a lot. Okay? Very nice. Oh, if I could do this mentally, it's square root of pi over 2, I think. Is it square root of pi over 2? Because without the 2, right, if we're only focusing on this, just do integration by parts and you end up with a Gaussian integral. And so you should get like square root of pi over 4 times 2. That gives you square root of pi over 2. So that should be the answer. Inverse sinh. Oh god. Integration by parts. I don't know what inverse sinh of 3/4 is. I think, was it ln of 2? I don't know. I'm just thinking in my head. It might be ln of 2. I could be wrong. This would be like my safety answer. If I can't think of like the logarithm version on top of my head, I'll just write it like this, just to stay safe. Too easy. Too easy. We all know this. Integrate by parts. That's all you gotta do. Integrate by parts, you get x ln of 1 plus x squared. And then you get something like some inverse tangent minus. No. Yeah. X minus inverse tangent, something like that. You get something. You get left with an integral of like x squared over 1 plus x squared, something like that. Too easy. Oh my god. Isn't this just x to the power of 8? 1 minus x to the power of 8? Easy algebra. Oh, this is tiebreaker. I just realized. That's why it got easier. Okay. Yeah, 1 minus x to the power of 8, that should give you 1 minus 1/9. So the answer to this integral should be 8 over 9, I believe. Oh boy. Let's go. Sine squared type. I feel like we've done this before. I don't know why, but I feel like we've done this integral before from 2024. The reason why I want to do this u substitution is because from 0 to 2 pi, I thought we could do like periodicity. So that's why I wanted it like this. But remember, we have squares. So because of that, let's see. Square, I think that gives us another half. Yeah, that does give us, that's not a can't speak. That's not a plus, that's a minus, right? Cosine of u, something like that, or 2u, right? But obviously by periodicity that cancels out, so our answer should be 2 pi times 1 over 16, which means that the answer should be around pi over 8. I can't speed integrate when I'm freezing. Alright, let's go next. Oh, you son of a... God damn it. Alright. It's bashing time. Well, it's actually not too much of a bash. I'm just very lazy. Honestly, I should have done it the other way, actually. You know, if you end up something like this, do sinh first. Then sine of x. And the reason why I like to do this is because it's easier to keep track of the alternating stuff, you know? Like, because I know, like, for hyperbolics, there's no negatives and positives to deal with, right? So, you don't have this kind of distracting you. Here, you have to watch out for, like, signs like this. Okay? So this is literally our answer. It's just a half of cosh pi over 2. This is evil. Just some random log 2 base. So this should be what, ln of ln of, so let u equal ln of x, then you get 1 over x ln of x. Yeah, so you get ln of x over ln of 2. So you have ln of x. You have ln of x. It's crazy. So plugging these, you get 4. You get ln of 4 minus ln of 2. I'm doing this all mentally because I know I could do this mentally. Wait, ln of 4 is ln of 2 ln of 2 minus ln of 2. Oh, and that equals to ln of 2 over ln of 2. Oh, so this integral is equal to 1. Nice. Next integral. Oh, you son. You are evil for this. You are evil for this. You know what? Joke's on you. We know gamma function. For just to ease your mind, you can let w equal u times 2026. Right? So you can just let that be here. However, the only annoying thing is it also affects this too. So you have to be very careful with that as well. So you get w over 2026 to the power of 2025. And so now what you have here is negative 2025 factorial, negative 2025 factorial, all over 2026 to the power of 2026. This is our answer. This is actually kind of interesting. I actually don't know how to do this. 2 minus cosine square? Disgusting. But, I mean, you know what we always do. Right? I hope you guys know what I have in mind. Inverse tangent. You know it. This is acceptable. Why is this acceptable? Because the inside of inverse tangent is less than 1. Right? If the inside of this number is greater than 1, we have a problem. Right? Because that's a complex number. So we have to be very careful. Too easy. What the fuck is this? What the hell? Alright, so whenever you got something like this, oh god. This is evil. This is worse than the that MIT integral from 2015. Which is a bunch of like 1 plus x plus 1 plus 1 plus 1 plus x plus 10x or something like that. But Jesus Christ, that's just evil. Okay, without using my cursor though. Let's see. That's how many zeros? 4, 6, 8, 10, 12, 14. Wait, I lost track. 4 without using my cursor. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Oh, you God damn it. Oh, that was a tiebreaker. I always keep forgetting there's tiebreakers at the end. But what an evil tiebreaker. That's an evil tiebreaker. Y'all are evil for this. That's funny. That's amazing. I like that a lot, actually. Alright. Semi-finals time. My hands are freezing. Jesus. Alright. Let's go. Let's do this. Yeet! Oh, too easy. I could do it in my head. Let's see. Cosine square. Yeah, secant x plus tangent x. Oh no, what am I doing? Oh, I'm integrating the antiderivative. No, the antiderivative is secant x plus tangent x. I don't know why I was integrating it. No. Yeah, the antiderivative is secant x plus tangent x. My brain is thinking too fast. I'm sorry. No. Okay. So it's like -1, and then pi over 3 should be just 2 plus root 3 minus 1. So it should be 1 plus root 3. I think that's the answer. 1 plus root 3. Anyhow. Oh my god. No. And I like how they didn't use ceiling function. Interesting. N plus 1. We have imagined this as n plus 1. So pretty much you get 1 plus n plus 1. Right. And then we have minus ln and then n squared. So we have 1 minus n minus plus n squared. Okay. And if you notice, this part is equal to 1 plus I was gonna say n minus 1 or something like that. But oh, it is. Yeah, yes it is. I don't know what am I thinking? Yeah, this is equal. Ah, so what do you guys notice? This is a you got this, you know what it is. Telescoping, right? There's a telescoping sum. So 10,101. This is our answer. Okay? That was actually kind of a cool telescoping sum. I never thought of it like this. This was actually pretty cool. That was a cool piecewise integral. I use this reverse quotient rule. It's like sine ln of x over x. Is that what it is? That it would make the most sense Yeah. I'm gonna guess sine ln of x over x. I think that's my answer. Reverse quotient rule. Okay. Oh no, don't give me this. Oh my god. So you would think this would equal to 0, but it's not. It is not. You have to be very careful. Harvard, MIT killed a lot of students with this. It's not as easy as you think. My brain is blanking for some reason. I cannot figure out how to do this for some reason. Oh god, this is how I would get eliminated. 2 to 1. Obviously this goes to 0, right? And from 1 to 1 over e, right, you get negative 1. And then from 1 over e to 1 over e squared gives you negative 2. And do you see the pattern? Right? And so on. Because you'll never reach to 0. That's the thing. So, what happens here is our actual true sum. We get 1 over e here, plus 1 over e squared, plus 1 over e cubed, etc. This is our true sum here. So it's a geometric series. We have negative 1 over 1 minus 1 over e. This gives us e minus 1. Okay, this is our answer. All right. Whew. Deconstruct the sum. You know, if you can't sum it, deconstruct it. Okay. Oh, these are tiebreaker. Too easy. Too easy. Laplace. Just use Laplace. Yeah. Tiebreakers are extremely easy, which is good, right? That means in tiebreakers you see two people racing at each other, and that's very entertaining. So, other than that, third place match. I'm a little terrified to what kind of integrals you have, but let's dive right in. Okay, this is actually not too bad. Inversion. Actually, yeah, inversion. 2x squared over 1 plus x4. So I believe the answer is pi over root 2. I think that's what it is. It's pi over root 2. Just do inversion, not on everything. Focus on this term, do inversion, and it gives you x squared over 1 plus x4. So you can combine it, so this whole thing becomes 2x squared over 1 plus x4. And then you could use Glasser's master theorem. Right. You use Glasser's master theorem, and that should give you pi over root 2. Oh, shit. Why? Why? Oh, wait a minute. Is this reverse product rule? Wait. Now, it's not. Okay. Man. Why are you gonna do this to me? Okay. Oh my god, it's so tedious. Why? Why would you give such an integral? It's so tedious. Well, actually, now I think about it, this is also kind of nice, because what happens is I'm left with this, right? And what you could do is you can go like, what we have here, right? We have x squared over this, but you can do plus 1, which is minus 1. And then this cancels out. That's honestly very sweet. Actually, now I think about it, this is actually this was very generous of them. So that saves a lot of work. 3/4, and then plus inverse sinh of 3/4. This term is very nice. That's a very nice term. Thank God. Thank God. Thank you so much for that. Okay. Even though this is a common integral, I can't memorize this at the back of my head. It's just tedious. Too easy. Okay. Oh my god. Why? Why? That imaginary eye is just cruelty. This is right? I don't know. This looks very sus. This is extremely sus. E to the pi over 2I. I kind of don't trust this. So is this 1 minus I? Is that what that is? I actually don't know. I don't know if it's 1 minus I, or if it's something else in real form. But I think it's 1 minus I. I think it's 1 minus I. Oh my god! Oh, it's tiebreaker. Oh, you gotta do this in my head. Wait, I got this. Log of e to the... Wait, what? Wait, log of... Huh? Wait, no, I cannot do this in my head. This is ln of x e4 2. This whole portion gives us ln of 4 minus ln of 2, which equals to ln of 2. And so we get 6 ln of 4. Sorry, 6 ln of 2 to the power of 4. I believe is our answer. Kind of a fun tiebreaker to give to students. Oh no! No! Oh, alright, let's go. I mean, this is third place match, so this is actually kind of fair. What am I doing? Why am I graphing? I shouldn't be graphing. What am I doing? This is speed integration. Silver doesn't graph. You know what I do? I do equations. That's what this is. So I need to find where they intersect. And if they don't, thank God. Oh, they do intersect. There's an intersection. So it's plus or minus. Thankfully, we only do a positive because it's only from 0 to 1. So we have square root of 2/3. I think this is my answer. God. Nasty. To the epic finale! Oh my god! Finally! To the epic finale. This one, I'm a bit scared. I am a bit scared. I'm oh god. Oh. Let's see where this goes. Alright. Hit it! Oh my god. No. Please no. Oh no. Don't do this to me. I'm gonna leave it like this. I'm too lazy. You can always leave your answers unsimplified. Okay, this is actually kind of interesting. I wonder if there's a faster way to do this. I'm really curious if there's a faster way to do this. I would love to know the faster way to do this. So because of the bounds, I'm gonna have the integral bounds are going to guide me. So let u equal 1 over x. Right? I don't know where this is gonna go. Oh, that's sick. Oh, that is sick. That's actually pretty freaking cool. So, let's see, that's like, this is what, u 1/3? Negative 1/3? So, plus 1, that's going to give me 3/2 of 2/3. So, is the answer 3/2? I think the answer is 3/2. I hope so. But that was a cool integral. That's honest. This is actually a very nice. This would be a nice qualifying exam integral actually. But yeah, that was cool. That was pretty cool. I like that a lot. Okay, this is evil. Wait, but you have secant x. Oh, actually, you let u equal secant x plus tangent x, and the integral is just u. Right? So the integral is a u from 1 to root 2 plus root 3? From 1 to 2 plus root 3. So you get u squared over 2. So you get 2 plus root 3 squared minus 1, all of that over 2. I think that's my answer. Mental integration. Let me know in the comments if I'm wrong though. Always. Always let me know if I'm wrong, please. This is Taylor series. Right. I actually can't do this in my head. Let u equal 1 minus x, then you get ln of 1 minus u. Oh wait, so would this be negative pi squared over 6? I think it's negative pi squared over 6. But I just did u equal 1 minus x, and then Taylor series with the ln of 1 minus u. Then you should get negative pi squared over 6. Should be good. Please don't do this to me. This is exactly how I feel when I get assigned with math homework. I get integrals like this. Oh no, you didn't throw this at me, did you? Oh, you son of a... Yes, you did. How could you? So it would be secant theta tangent theta minus ln secant theta plus tangent theta from 0 to pi over 6. I think that's what it is. This equals to 0. Okay. Holy hell. Oh, so much math homework. Ugh. Okay. So we get 75x. Everything is... Oh, no, but then you have cosine 0. Oh, okay. I lied. So then you should get something like 1 over 75 plus 1 over 27? Is that what it is? 1 over 75 plus 1 over 27. Yeah, because the negatives cancels out. Yeah, I think that's my answer. 1 over 75 plus 1 over 27. Mental integration. Oh my god. No! Oh my god. Okay, there has to be a trick to this. I really hope so. If not, then it's just me. Why? Why are you gonna do this? Why? This sucks. This really sucks. I wanted 2024. So now I have 450 minus 2024, which is 2026. And then this is x plus 1012. Why? 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 I do not want to solve this. I'm leaving it like this. You are not making me... Oh, this is inverse tang. Oh, you are disgusting. Oh my god. 2026 square root of whatever this is. Why? Why? Why would you... Who would thought this would be a good idea? Oh my god. Yeah, you get the drill. You get the drill. I'm not gonna write this whole thing. That's awful. That is awful. Oh, that's a tiebreak. Cruelty at its finest. Well, that's it. Holy hell. I don't know, I feel like a lot of the integrals were bashy. I think my favorite so far is this one. This is probably, out of all integrals, this one's my favorite. And this part here with the cube root, this scares a lot of people, right? But follow the bounds, right? Look at this, that u equal 1 over x. Okay, so the rest was kind of a bit bashy. Other than that, it makes sense. Like if you're more focused on seeing two students race against each other rather than trying to figure it out, then this is acceptable. I'd say this was perfect. I kind of have a good laugh too. Scare some people sometimes. But other than that, Thank you so much. Thank you, Bonn University Integration Bee, for sharing this. It was very, very fun. Holy hell, that was a lot of Bashy integrals, though. Other than that, thanks so much for watching. I'll see you guys in the next video. See ya.